Everybody, we're going to start in a moment. Just setting some things up on my end, guys. You can also check my goal that I've just created. If we get 10 of those super chats, then for everyone who contributed, they'll get all 3 courses on total development for €149, saving over €100. But you have to reach all 10. You have to have enough people who contribute to those messages for that offer to stand. All right. Let me share this around a little bit. I'm just going to LinkedIn a sec, posting the link to the stream there. Yeah, one more place to share this to, and then we can start. All right, let's begin. So, wait, we need to fix some bugs with the journal today. Once they were crashing the kernel last session yesterday. So we're going to fix all of those up, and hopefully everything will work okay. So we're going to look through a couple different areas in the system to try to identify what's causing it. And from that, we can resolve the problem. So Yeah, we're gonna start looking now. Let's start with the commit, checking the commit, because we did see a couple bugs there, didn't we? Very hot today, guys. 30 Celsius here. Okay, we have a question here from Jama Tortiz. Hope I said that right. Um, his question goes, how do you handle massive kernel compatibility, like handling kernels from 3.x and so on? Well, actually, the Linux kernel won't load a module that wasn't built for it, for its version. Um, that's why if you install VirtualBox, for example, and you have they have the virtual driver you can install that lets you transfer files and it makes the screen full screen. Notice how it compiles that from source. That's the reason why. So that's how you handle this. You ship the source code, not the binary. And then if there's an incompatibility, say the API has changed since version 3, it just won't compile because there'll be some syntax error, right? So then what a developer will do, it will use some sort of definitions to check the kernel version, and it'll change its code accordingly for which kernel it wishes for it to compile on by using like a C macro, if and def, things like this, right? Or if this is equal to this, then we're on version 3, for example, then use this code, else use this code. You get what I'm saying? And then it gets compiled from source. So that's how it works. Yeah, but that's the way it is. That's the way it is. You can't load modules for a kernel that it wasn't built for by design for safety reasons because the API can change. So that's why most people ship the source code and then they have some build script that'll build it. All right, so there we are. I answered your question. I'm gonna go back to the work. Don't forget, guys, if I get 10 of these smart chats or whatever they're called, what are they called now? Some sort of YouTube goal. It's the first time I've used that. If I get 10 of those, everyone who contributed to those 10 will get the full 3 courses for 149 euros. Okay, but the rule is we have to reach 10. Okay, within 2 hours. So if you're interested, drop that in. But you only get the discount if we reach 10 of them. Okay, that's the game. All right, let's get back to work. I gotta sit up for this. It's getting serious. So hot. Let's start looking at the shrink and see if we did that right. So we know we get a crash, so there's definitely something wrong in one of these functions. I've actually already found an issue on line 272. Total mem elements new. List t size, that's wrong, because that's the total elements. That should be 1. Because the idea is that if the total size is 0, because we shrank down too far, well, we can't reallocate to null. That would just be stupid, right? So instead we reserve 1 element, and that's it, in memory, not in the list. It can still not be there, but the memory for it will be. All right, let's check another bug here. I just found another one. We set the list pointer, but what if k-realloc fails? Then we get no pointer dereference here. Well, I guess no, we don't. We get a memory leak because the pointer goes null. So we need to solve that. There you go. That'll just preserve the old pointer in the event that the reallocation fails. Much safer that way. Yeah, the kernel supports reallocation. It supports most things, actually. They're just under different names. Like when I say most things, I mean most things in terms of like what you would expect from a basic program, like memory management, things like this. Doesn't support memory mapping and things like that. I mean, you can write your driver so it supports memory mapping for user programs, but what I mean is I can't just mmap the entire file system and access it through a pointer like I can in user space. That's not possible in the kernel. You could probably find a way to hack it, but I mean, it wouldn't be worth it. It wouldn't be portable at all. All right, let's carry on. So there's some bugs fixed. Let's go back to the journal so we can find anything else. So when I rewrote the wrote the user program for creating the file system, I just use mmap because it's easier. Then I can access the whole thing as to a pointer, yeah. But the problem was I didn't account for the fact that we're not going to be able to do that on the kernel, right? So to make my code portable, I created this function, Peach VFS address pointer, which will basically, it's not memory mapping, okay? It's not, but it'll load the whole thing into a buffer so you can access it and it'll flush it back. That's not the best idea, to be honest, but it's like prototyping, right? I'll show you how it works, actually, how I did it for those interested. So we have this system I built, the disk pointer system, okay? It's better I show you from the header file. Yeah, so this is how it works, right? So we have the Okay, that's better. The microphone disconnected. Sorry about that. So what I was saying was we have the pointer here. This points to the actual memory that's concerned. Yeah, this should be on disk. So it loads it into memory and it points to that. Then you only pass around this pointer on line 33, and it will subtract the difference to locate the disk pointer struct. So it's like, but it's interesting how I did it. But obviously, if you pass in the wrong memory, that's why we have the signature, okay? But it's not foolproof because it's still possible. The memory, if you pass the wrong pointer, reacts to something that was never mapped into memory, like it was never allocated, for example. But it's a fail-safe just in case to try and catch some things. So essentially, what you can do, you can see disk pointer get here. You pass in the actual data pointer and it returns you the disk pointer structure here, right? And this was just a way I made to make my code portable because I wrote the whole application, the user space app. I wrote it entirely in with memory mapping. And then I realized I'm gonna have to rewrite the whole thing for the kernel because it's not compatible. So this was a little solution that I came up with. I don't know, I'm pretty happy with it. I think it's creative, but a bit dangerous. Yeah, we use copy from user. You have to use that in certain functions. Um, that's important. In the write and read functions, you need to concern yourself with that, with those types of functions. Right, let's get back to it now. Let me check the journal now. So in my journal, we call this safe function. It just checks all the checksums match because if you have a hard disk, over time bits can flip, and this is problematic, which is why we check the checksums. So if you leave a hard disk on the shelf for 10 years, we'll know if the data is still safe or not. All right, so I explained a bit of the design. Let's go back to this now. We're going to try and find these bugs. We fixed one already. Okay, the commit looks all right so far. I can't see anything obvious yet. Let's try the restore. Let's check this destroy because it destroys the journal when it's done committing it. Okay, let's check this function. I hate when Visual Studio Code does this, when it opens a separate dialog. It's so annoying. I need to find a way to disable that. Let's check the empty function. Oh, well, I disabled it, and I forgot to undisable it, so that was stupid. Let's fix that. Okay, what else do we have? So obviously this OS is this VFS driver is designed for teaching purposes. That's why I've taken some special little shortcuts, like loading the whole descriptors into memory, things like this. Things you should never do on a production system. But this was intentional because I'm trying to keep the content as simple as possible for when I actually teach people how to make this exact file system. Again, keeping that memory mapping type of style, but it isn't actually happening, but illusion. So that was intentionally designed to do that in this way. But really, you should avoid doing things like that in a serious driver. This is manageable because one cluster uses 1 byte. Again, if I was writing this for a production purpose, one cluster would be 1 bit or 2 bits. It wouldn't be 1 byte. Again, simple design choices for teaching. Right, so let's see, what else have we got? We made another mistake here because we removed the flag here, cluster 3, instead of added. So that was a mistake I made. Let's fix that. Okay, so that's added now. We'll check some other stuff. Okay, that's fine. All looks good to me. Okay, should we try it again and see if we fixed it? Let's find out. Okay, so far so good. Let's try and create a file. Looks good. Now let's try the thing that broke the whole system last time. Let's copy the include directory straight into our mount point and see if the kernel crashes like before. Hopefully not. Nah, damn it, we crashed. Ah, I thought we fixed it. There must be another bug somewhere. We're gonna have to try and find it. All right, I'll be right back after a cigarette and we're gonna get on with this. I'm back. Right, let's go back to it. I appreciate you like my video, guys, because it helps me get some more traction. Let's try not to crash the kernel this time. I have a rough idea what it could be. I think we might have caused some memory related issue for sure. We're not going to run anything until I've looked at this code properly. I don't want to crash it. Let's just commit as well, in case we crash again. Because of journals, why we survive data crashes. That's why they're so valuable. That's why I built one for our VFS, which will be in the course, by the way. Listening to some amazing tracks. Can't play it because of the copyright, fortunately. Yeah, this. What am I doing here? Because I'm loading the whole journal in memory. That could be an issue, really. I mean, again, I tried to do it to simplify for the students, but I can only bend the rules so much, right? Maybe I will try and see if I can make a way for memory mapping to work like this in the kernel, like it would on user space. Maybe I can figure it out. But it would be a hack, I'm pretty sure. That's why I'm avoiding it. No, it's not as bad as I thought actually, because we don't load the data. So that's good. Let me check we computed the size correctly since we don't load the data. Ah, no, wait a minute. No, I don't think we do. Yeah, this could be a problem, what we're doing here. We have a new question. Let me see what it says. Hold on. Again, I don't see your questions right away because I don't have a second one of the guys. So this is from Yutka Yutkash. I apologize if I'm saying your name wrong. How do you manage to remember so many lines of code? That's impressive. Well, thanks. I don't see the code. I see the system. So when I work on a project, I sort of just see it in my mind, right? So it's like me trying to say to you, how do you remember exactly the words that you need to say next in a sentence? They become a part of you, right? It's the same with the code after a long time. This is just what happens. So when I started the journal, for example, I just saw the ideas in my head of the abstraction, how I'll make buckets, which will have different types, they'll be responsible for different things, that will be organized this way on the disk. Then I write the structures from my memory, from what I'm imagining. And then from the structures comes the logic. And then from the logic comes the bugs and the functionality. Um, so that's how it is basically. It's like when I say to you, how do you think what word to say next in a sentence? It just comes to you, right? It's the same thing when I'm doing these things. It's hard to explain it. I think it's just because I've been doing it so long. I think it just comes to me. Um, that's why I don't have to plan very hard. I never write things down. It just comes to me as I'm working. Of course, I don't always get it completely right. Sometimes I'll refactor things later on or change things, but the general ideas come quite strongly, and then I implement them as they come into my mind. But I see the abstractions, so it's not like I see 10,000 lines of code. I see the abstractions as separate objects in my mind, the same way you might think to take a next step. You don't know how you're walking, you just move your legs. It's exactly the same thing that happens to me. It just comes to me. That's how it is. But I think I just developed that because I've been doing it from a child. So I think that's why I have the ability to do that. I think you develop this after a long time of programming. Okay, back to it. Yeah, so the issue might be that the because we load the whole journal into memory, we could be loading too much data. That could be the issue. Let's shrink the journal and see how that looks for us. Again, we shouldn't really be doing that. I simplified it because I plan to teach people how to make the journal. I want it to be as simple as possible, right? You would never do that in a production environment, load the whole journal in memory. if it's like many megabytes. So the journal is currently 20 megabyte. Let's change it to 5 megabyte and see if some of those issues go away. That's less memory for it to load into memory. So this total bytes here could be actually wrong. Because it's not stored linearly, I don't think. Yeah, as you can see, the data is loaded separately and written separately to a separate cluster. And the address is stored in the data address. Yeah, we only care about the metadata for the journal size. I think we need to change the way that works. We're going to do that now. There we go. So we fixed that issue. That's great. I don't think that it's necessarily a bug in the fact that it's going to crash the kernel, but it was a memory related bug in that we declared too much memory, more than we actually needed. So that's resolved. Abdul says, keep it up. Love you. Thank you, man. Thank you. I love you all too. Right, let's see what else we have to do here. Just double check some things. Everything else looks correct. Okay, that's one issue solved. Let's commit that. Since I don't believe that would be the bug that caused the crash, we're gonna keep looking to see what the bug was. It's gotta be somewhere. Aha, I found another bug. We have to mark all of them as taken because otherwise they'll be overwritten by the next call to bucket classifying. That could explain our crash actually. Now I think we found something that might be causing the crash, yeah. Now this one does mark found taken, so that's good. All right, I think we've found the issue that was causing the crash, so let's try again and see if it runs this time without a crash. I'd rather see some error codes than a crash. Don't forget, guys, my courses are on discount in the video description. If you want to learn how to build kernels from scratch, please get them now. I will also be making a course on this project, on how to build this exact project. That's why I've been working 3 months on this. The courses do take a long time to make. They take over a year. That's why the prices are a couple €100 in many cases. So because I've worked on them every day for free for over a year a lot of the time. Right, let's continue. Let's see if this works. So far, so good. Let's commit something to it. Very, very nice. All right, let's try the copy again. And this time I really hope we don't crash the kernel. No, we crashed it again. Oh, what else could it be? We can see that writing the files works totally fine. But when we copy from user include, one of those files is stripping this up. Maybe because we copy so much files, maybe at some point maybe we're corrupting something in the data structure that I did in the data structure that I didn't account for. Perhaps this is possible. What we're going to do, we're going to try and manually create many files, and until I can find out myself if I can crash it that way, and then we can work from there. Okay, I'll be right back, guys. I'm gonna have a cigarette while this reboots. I'm back, guys. Oh, no way, it's still not booted. Okay, let's try a hard reset on that. Is this what happens when you do the kernel dev? You risk destroying your system, you know, it's a big deal. That's why I have a snapshot. No, I'm to answer your question, Patry, if I'm saying that right. I'm not loading my kernel into Linux, into the VM. I'm making a virtual file system driver. So what that means is that on your hard disk, files don't exist. You just have blocks. So your hardware, your kernel will say load block 5 from the hard disk. Yeah. The files only exist in an operating system. Only the operating system understands files. We're building the part that understands the files. That's what we're doing. We're modifying Linux to do that with our own file system that has our own file system structures. If you've ever formatted a USB stick, you'll see this firsthand because it'll say which file system do you want, FAT32, ext4, you know, things like this. Um, so yeah, that's how that's working. Well, I'm glad we could boot, so the kernel's not dead. That's great. Let's try and find our bug. It's a quite complicated problem, to be honest. I mean, it seems simple. A read-only file system is really easy because you can just store the data wherever you want. But the moment when you need to actually write to the file system, it's much more complicated because there's some other data that's after the file, and then you need to skip over that data. So how do you do that? Well, you make a data structure that tells you where the free blocks are, things like this, right? And the journal complicates things even more because the journal's job, which is where the bugs are now, is to save your operating system in the event of a crash. That's the point of the journal, to minimize data corruption. So if you pull the power cord out of your computer, out of the wall, the only reason your computer reboots is because of the journals. That's the only reason, because otherwise the file system will be corrupted. The journal works like a database transaction. You know how in database you can have different queries and you commit them? It's the same idea. So it'll be like change this block, change this block, change that block, and then you call commit. It's the same idea basically. It's data integrity, guys, right? Let's try and find this bug then. I have no idea where it is. We fixed a couple bugs since in the last 60 minutes. How many bugs? Like 3, 4 bugs I fixed already. Let's keep looking for them. It's very hard because I don't have a debugger attached to the kernel. So I'm just like, I'm blind. It makes it more challenging, I guess. I probably should have recompiled the kernel with debugging symbols really, but never mind. Let's have fun. Okay, let's go to the dot write and see if there's any issue with the actual writing. Maybe that's where the issue is. Because we're assuming it's the journal, we don't know that. I put this byte count rule because I'm aware we load a lot of stuff in the memory, more than you would ever do in a production driver. Just because it's easier to teach the students that way, right? They don't have to know as much. That's why I have that check. Could we be having some sort of locking issue? Some sort of deadlock, maybe that could have happened. Let's check if I'm locking the inodes the other way around in some other place. No, it appears I'm following the rules correctly. You can see we locked the mutex for the instance after the inode was locked, which is the correct path. We'll unlock it again, we copy to the user. And then we finally unlock the inode, that looks fine to me. Here we only lock the instance. That should, could that be a problem? Let me think about that. Yeah, what we'll do, we'll remove the inode locking for now, and we'll just lock the instance. It should be okay because we have the locking of the instance in every function. And then we'll see if that helps. There's no obvious deadlock right now, but just in case. So we'll lock it there. Okay, and then we'll unlock it at the bottom. Okay, that looks fine. Alright, that looks okay now. That should be fine. I don't think there is a deadlock, I just want to take precautions. Okay, party. Take care, party, and Patry, sorry. And yeah, check the courses out if you want to learn kernel development. They're on discount, they're in the video description. Check those out. You can learn how to build an OS from scratch in 69 hours. Or if that's a bit ambitious, I have shorter courses there too. The Power 1 course. The Power 1 course. Okay, I think the journal is fine now. I've checked it over. Let's check the file system functionality, make sure we're not missing something there. We can also, if we crash again, we can disable the journal just to completely rule out if that's the problem. Look at this dialogue thing. I hate that Visual Studio does this. It's awful. Right, let me open that in a new window. That looks okay so far. Let's check the file extension works as expected. Yes, there's a potential. Oh, no, this is okay. We checked for that. So when we reach the end of the table, we branch off to another, basically a pointer to another table, essentially. No obvious problems yet. So basically, how it's working is the file data address will get replaced with a new table. So rather than copying over the table every time we make a change, we just change the pointer in the file to point to the new table we're making, essentially, guys, and we have a pointer back to the old table within that table. It just saves us having to copy the table over. Much faster that way, right? Yeah, this looks fine to me. I don't see any obvious overflow. I even wrote a comment. Say the code looks right. I don't remember writing that. Okay, great. We'll keep checking. That looks fine. File writing looks completely correct. I want to check the bit where we actually create the file descriptors. Check when overflowing there. Yeah, that looks correct. What we do is we calculate the offset for the table here, the correct table, and then we find out what's left and we calculate the relative index, and then we pull the record from there. Because it has pointers to different tables. That's how it's working. But I don't see anywhere where we create a new table if we run out of room. Maybe that is one issue. Okay, maybe we handle that somewhere else. Let's check. No, so we don't handle that. So that explains a lot then. Because we don't handle that situation. We run out of records that obviously needs to be dealt with. So we're gonna have to deal with that. Okay, we'll deal with this now. Yeah, so how we can do this, we just loop to the very last structure pointer, to the very last file index, because that's where the structure pointer is expected to be. And we just loop over it until we get where we need to be. That's how we'll handle it. Let me write a little comment to enforce that contract though. That just simplifies the design by enforcing that. Perfect. That'll work well. Okay, guys, I'll be right back. I'm just gonna have a cigarette. But yeah, that function's done. Hey guys, I'm back. Thanks for waiting. Okay, let's begin. Does anyone want some like AI music? Let me know. I can't play the copyrighted stuff or I'll have my channel deleted. Oh, I even put a to-do. I planned to do it. I just didn't get around to it. So we want to change the way this works as well, because you shouldn't have the last element used as an empty slot. It's reserved. Hey, welcome. We also clean up the old pointer here, so it's better we just take the address. But we also need to ensure, the first thing we need to do is ensure that we do not take the last file slot. That's so important. Currently we do. And that'll guarantee the last file slot can never be used. Put some background music, showing. Let's put some on. So I could write this in a more optimized way, but because it's for teaching, I want to make it as simple as possible. So we'll actually reparse where the actual end of the table is, even though we can calculate it from the address and the empty slot function. I'd rather just do it like this because it simplifies the code for the students. But if you were doing this for production, you would definitely try to make use of what the last address was, so you didn't have to go through the table again. Let's put some music on. Hold on. I think I've already done something here. Hold on. I actually did this already. Aha, but we use a different function. Okay. This is the old work, I think. I don't think this work will work anymore. We've made some changes since then. It's okay. We can just rewrite it because I don't trust us. This is the old work from before. I think we can reuse some of it though. We'll just copy this and we'll change what needs to be changed. I have to remove those old functions later because they're very confusing because they shouldn't be there anymore. Changed the system too much since then. But that function will actually be compatible with this. We can work with that. Okay, that's given us the last slot. Let's do a sanity check before we do anything. All right, that looks great. We need to deal with the situation if it's already a cluster pointer as well. Oh, but then again, if it was already a cluster pointer, then it would be then it wouldn't have been the last table. So I don't think that case can ever happen. So we should remove that from here. There we go. Perfect. That's great. Oh, that looks correct to me, guys. I'll be right back after a cigarette, and then we're gonna call it and see if it works. I'm back, guys. Thanks for waiting. This function should work. I think so. Okay, let's test it. Possibly some compile errors. Okay. Will it compile without compile errors? Probably not. It never usually does. Let's see. And it did. Must be on a roll today. Okay, let's try it. That's the first file. Let's keep making them until we pass 20. Hopefully no crash in the meantime. And it worked. Let's see if we have all those files. And we do. So we fixed it. It's great. Let's commit those changes and then we'll try and copy the input directory again. Now it's the test. Ah, we crashed again. All right, so we fixed some issues, but there's still a problem with it. So I have to look into what that is. But I'll stream again later tonight, most likely, guys, because I have things to do right now. But we will get this fixed soon. Check the video description if you want to learn how to build your own kernel from scratch. There's 69 hours of video. If that's too much for you, get the part one. Now just 99 euros. That's 29 hours of video. These courses took years to build. Working every day on them for like over 2 years for free. So they're priced very fairly, given the amount of effort put into them. So check it out if you're interested. Get them. Offers don't last forever. Okay, thanks so much for watching, guys. Stream again later. Please subscribe so that you can continue seeing my content. Thank you very much.